My name is Markus Lehtonen, and I'm going to talk a bit about building and maintaining RPM packages in Git repositories using Git buildpackage tool. A short intro. So I'm working for the Intel Open Source Technology Center Finland office, and one of my duties has been participating in the Tizen project, which of developments of which this presentation contains. Outline of my talk. First, I'm going to represent your problem that I found. Then shortly talk about the Debian and the Git build package tool there. Then present our solution to the problem, Git build package RPM toolset, and do a little bit deeper dive there, and then demo the tools. Then talk shortly about a future development, what I have in mind, and if I have time, I can shortly talk about the build setup which we have in Tizen. First, the problem. In RPM world, the package maintenance and software development, in my opinion at least, has some problems. There are so many different practices how packages are maintained and how the packaging metadata is stored. Different practices even inside or between different developers inside one distribution. So the tracking of history of the packaging metadata is easily quite error prone or haphazard. Then often there is no clear separation between real upstream sources, then local code changes, and then the packaging data. And of course, what adds to the confusion is that people from different projects or people with background in different projects, then when they come into a new project, they have different practices brought from those, for example, federals use. And then, of course, one problem that I see is that packaging and releasing your changes can be a little bit awkward. Always editing the spec file, doing the same things, adding the patches there, and generating the patches, and so on, so forth. In Debian, however, they have a long history of maintaining packages in different version control systems, and they have some good package maintenance practices as well. They have for maintaining packages in version control system, they have many build package tools: SVM build package, HG build package for maintaining packages in Mercurial, or Git build package for Git. And it seemed that like to have something similar in the RPM world as well. And Git build package seemed to be one good option for that. Shortly about the Git build package in the Debian world. I don't know how many of you are familiar with the tool set. Just quick poll, raise your hand if you know that. Okay, there are some people, so that's good. I'm not that familiar with the toolset myself because I've mainly worked on the RPM side, but anyway, Git build package is a set of tools for maintaining and building packages, Debian packages in Git repositories. It has multiple separate command line tools for importing Debian packages to JIT to like initialize a project, then cloning and updating repositories which are maintained by or with the JIT build package tool. Then it has got tools for importing upstream released upstream source tarballs into a JIT repository. Then builder tool, of course, for helping building packages out of the JIT, and then changelog management tool as well. And all in all, the Debian tools help in keeping the packaging consistent, at least in my how I see it. That helps to keep consistent branch naming JIT, then consistent tag naming and tagging of releases, helps in patch management, importing patches to your JIT and then generating patches out of there. Then helps also handling upstream sources, so importing new upstream versions and keeping everything in shape. And then it's also integrated with the pristine tar tool, which can be used for getting pristine, like bitwise identical tarballs or release tarballs out of JIT. By the way, if you have any questions or I explain something in an odd way, please just interrupt and ask. So all in all, JIT build package, how we saw it in Tizen, it provided an easier and more, or helped to get helped for easier and more consistent development and package maintenance. Simple in a sense that all packaging and sources are stored in JIT. It's easy to track history and build any released version of the package. It also helps developers packaging their local source code changes and helps them test that the packaging is correct, and also helps in submitting their changes either directly to remote JIT repository or for review in mailing lists or Gerrit, for example. And then it helps maintainers to release their software as well. For example, changelog management and tagging are good. Release tagging are good examples of that. And in my opinion, there's that consistency makes it also a lot easier to employ automatic building and test machinery across the distribution if all or most of the packages are maintained with one tool or few tools. So I must excuse my artistical capabilities, but here is how I see that JIT build package fits in the development process. So it mostly helps packaging the stuff, but also helps developers testing, and also helps in releasing the changes. Then to our solution, JIT build package RPM. We decided to go this way because we had two constraints. We had to use JIT, and then we were tied to RPM as well. However, we didn't want to reinvent the wheel again, and thus decided to try to extend the existing Debian tool set to support RPM packaging as well. And as a result, we ended up implementing experimental support for RPM, and I call it JIT build package RPM suite. Everything I present here is already publicly available, and the target in the long term is to get everything upstreamed into the Debian JIT build package. Goals in this exercise were basically support all the features that the Debian toolset has, reuse code as much as possible from the Debian side, and also try to enhance the code and contribute back. Then one of my goals was to try to be distribution agnostic, in the sense that you could use the toolset for developing in any RPM environment, OpenSUSE, Tizen, Fedora, Mandriva, whatever. So also because of that, it requires for the toolset to be flexible for different development practices and back-end infrastructures, so to support the different workflows and different kinds of maintenance models of packages. And also one goal was to help or to be able to do cross RPM distribution development, so that was also important for Tizen, so that you could, for example, use Fedora to develop for Tizen. The concept in the JIT build package RPM toolset is pretty simple in general. So everything is in JIT. The source code, upstream source code, all the packaging files. So from the previous session, you remember packaging spec file, possibly a changelog file, patches, additional sources, license files, whatever, and then and then the one thing is that we don't have the upstream source tarball or source archive in the JIT though. So the source tarball is generated in build time from JIT. So we don't store any big binary tarballs in JIT. And in JIT build package RPM, the spec file is the central piece of packaging information, upstream version, release version, name of the package, and so on. So this toolset or suite is a set of command line tools like Debian or similar to Debian. It has fairly few dependencies, only Python 2.6 something, I guess, would be the minimum version. Then we use RPM Python for helping in parsing the spec file, and then JIT, of course, is required, like as a hard requirement. Then you can have this pre-stintar tool, for example, if you want to use it, but it's not mandatory. The feature set is pretty comparable to the Debian tool set. JIT build package RPM supports importing existing source RPMs into a JIT repository. Then it supports cloning and pulling, or cloning and updating from remote repositories that are being maintained by JIT build package. It also similarly helps has tools for managing upstream sources. Then of course helps building packages and separate tool for patch management. And patch management is one important feature of that is that it has automatic like update of the spec file, so it puts all the patch tags and macros in place automatically, so you don't have to or need to edit the spec file manually. And this RPM toolset integrates with pristine tar as well. So pristine tar is usually used in the Debian world, but we've used it also in the RPM world. So as I said earlier, how many you are familiar with pristine tar? So at least some. So it's a tool for importing like release tarballs into Git repository, so that it generates delta information from the Git upstream or Git release tag and between the data that is actually in the tarball. Oh shit. So as a result, with the pristine tar tool, you are able to check out from the Git repository exactly the same tarball that was released in the project's website. For example, the release tarball might contain AutoTools macros or something, some additional data that is not found in the Git repository. So now I'm going to present all the separate tools in the Git build package RPM toolset. Let's start with Git import sRPM. The names are quite horrible. This is a tool for importing existing source RPMs into Git repository. So again, here's a fine illustration of mine, trying to illustrate what happens. So first you have source RPM, upstream version 1.0 and release 9, and then you run the tool, and it creates a Git repository and puts there two branches. We call them upstream and packaging branches. Normally the packaging branch is normally called master, so master branch. But anyway, so it finds the upstream tarball from the source RPM and commits that into the upstream branch, or contents of that into upstream branch as one commit. Then it takes all the other files in the source RPM, so the packaging files, so to call spec file patches and so on, and commits them into a separate branch called the packaging branch. So now we're somewhere here. And now this illustrates the case that the tool automatically imports all the patches that it founds automatically on top of the source code tree as well. So what it really does is takes the upstream sources, commits them to Git, then adds the packaging files in a separate directory there, commits those in, and then imports the patches into the source tree. And some features, it has separation for native and non-native packages. More of that later, a little bit later. Then automatic patch import if you want to use that. So to get patches into the Git tree as one commit per patch. So in this case, we would have 2 patches, for example. And then it has option for filtering the upstream tarball. For example, sometimes it might have some source code repository metadata that you would possibly want to filter out before committing it to Git, and also pristine tar support. Then the next tool is Git import orig RPM, even more horrible name. This is tool for importing new released upstream tarballs into Git repository that is being managed with Git build package. So this picture again tries to illustrate what happens. So now we had imported this package or existing source RPM into Git. Then we want to do a version bump to version 2.0. We have a released tarball, and then with this tool, it commits the contents of the source tarball into the upstream branch of the Git repository, and tags it accordingly. So pretty simple. Now, if you want to make a version bump, you'd basically only need to rebase the packaging branch on top of the tip of the upstream branch. Pretty similar features to the import sRPM. So you can filter out some data, source version control metadata or big test data, for example, if you don't want to have those in your Git repository. Then pristine tar support as well. And something to mention about pristine tar support here is that it also supports like mangling the prefix and tarball name of the source tarball when importing it to pristine tar. And then the tool has also options to help you importing release tarballs even if you are following the upstream Git project directly. So you can have like upstream Git branch called, for example, mainline, and then you would have import the release tarball on top of that, and then have a packaging branch in addition. Then 2 commands just for syncing with or getting changes from remote repositories. These are basically the same tools that the Debian side has, GBP clone and GBP pull. They're pretty simple tools. The benefit of them is that they automatically get you to track all relevant branches and also track and update all the relevant branches, and also create local copies of all the relevant branches. So if you do git clone, you would only get master branch. But if you do GBP clone, you get upstream and local copies of the upstream and packaging branches as well. Some few patches of these are not still upstream, but basically they're identical to the Debian side. Then to the build package tool itself. So it's a helper tool that doesn't actually build anything itself. So it prepares the sources and packaging data for an external builder tool to really build the package. In the simplest case, it would be RPM build, for example. Or then in a Fedora case from the previous presentation, you could have a mock builder script, for example, so that Git build package prepare the sources for mock and then just calls mock, and it will really build build the package. So it's basically for exporting, building, and tagging the releases or packages. It has like several phases in the process. So there's a clean phase that, well, all of the phases are optional actually, so you can skip any of those basically. But there's optional clean phase where you, with which you can like clean the build area. Then there's export phase with which exports or analyzes the version you want to build, copies the packaging files, spec, and so on into the build area, creates a source tarball for you, copies that to the build area as well, and possibly generates patches, copies those to the build area as well, and then the export phase is ready. Then finally it calls the builder script, which does the actual building. So this build package outsources building, always outsources it to somebody else. And then finally, there's optionally, you can tag the commit that you built. It has many configuration options for different kind of things. First of all, what you want to build, which revision, options for source tarball generation, how to generate that, which version, do you generate it from pristine tar, some tag, branch head or whatever. Then many options for automatic patch generation. You can exclude some patch or exclude some commits, patch compression, and so on. Also many options for tagging, tag format, signing tags. And then it has many hook options that you can run hooks after each of these phases of the build. So you can, for example, after exporting the sources, you can run some external script that will still do some modifications to the sources before building, calling some makefile, whatever. And the picture here tries to illustrate what happens. So we had our Git repository here, 2 branches, upstream and packaging. It basically takes the looks if we build the tip of the packaging branch, takes the spec file from there, copies it to the build area, and generates tarball from the tip of the or correct version of the upstream branch, and then generates patches from the upstream of head of the upstream branch to the head of the packaging branch. So here you would have like source code commits in the packaging branch, and it would generate 1 patch per Git commit. And after that is finalized, it would call RPM build, which would build the package in the build area, and finally RPM build will give you the source RPM and RPM packages. So I guess at this point I could give a short demo about the toolset so that you get some impression how it works. So I've just copied 1 package from OpenSUSE random package jetlib 1.2.5 and release 8.1. And then I also fetched one or next upstream version of the package. So let's start with importing the package, git import srpm, and then just give it. We want to put the packaging data into a separate directory called packaging, and then here we go. So now it imported the zlib package into a new directory called zlib. It warns about, it imports the patches, and it warns because it doesn't find any authorship information about those packages. They are just plain diffs without not generated by JIT. So now we are in the zlib project, and here we have two branches: master, which is now our packaging branch, and then upstream. And if you look at the contents of the package branches, we can see that, well, upstream only has one commit, which is the upstream sources in one single commit. And then if we take a look at the master branch, it has more commits. So first of all, it's based on the upstream. Then in the first commit, it basically adds all the packaging files into the packaging directory that I defined. So license file, whatever there was, and patches and spec file and so on. Then it automatically imports the patches. So these are the next commits. All the patches here are imported into the source tree, one commit per patch, like this. So these are the 3 patches, and then the last commit is actually git build package. It removes the patches from the packaging directory and the spec file as well. So for example, if we take a look at the last commit, it has removed the patch tags and macros from the spec file. Then we can try to bump to a new version. So I'm here in the zlib project. Let's import the new version. To the Git repository. It asks that the version number is correct. What did it do? Okay, I had the wrong option here actually. It tried to merge the upstream sources to the packaging branch. Let's okay, now it has actually imported it. So it tried to do a merge. You can prevent that by giving a separate option. So now if we go take a look at the 10 minutes. Okay, try to be quicker. So upstream, it has a new upstream version imported. And then if we take a look at the master branch, it's still 1.1.2.5. So if we want to do a version bump, I would just do git rebase upstream. And well, I don't want to. Let's see, all the patches were upstreamed already, so I squash this. And now we are rebased on the new upstream. And then what I need to actually here still do is edit the spec file and set the upstream version to 1.2.6 so that it would be correct. Where am I? Then shortly, still one more tool. So there's possibility to have separate packaging branch for the packaging metadata. So in this case, the packaging branch has no common history with the upstream branch, or and development is done on a third branch called development or patch queue branch, and then patches are exported into the separate packaging branch, and the package is released from there. Some common features of the tools: flexible branch naming, tag naming, and pristintar support, and configurable directory for the packaging files. Example workflow would be set start point, clone or import the existing package, develop, test, commit. You can test building the package as well, and once you are satisfied, build the package with GBP, and if you want to release it, also use the tagging feature and push to Git server. And actually we have one I could have shown it here. Shortly is actually building the package. So let's start again. So Git import. Now I import again the old version. Then I go to getlib and then just give it git build package, and well, let's build, for example, in the previous directory, and then rpm build pa. And now what happened? Oops. Did I do? Okay. That uses rpm build, and now if I take a look at the build directory, it has all the stuff it exported. The rpm build the package there, so you can find the RPMs and source RPM there. Very shortly about the maintenance models that tool supports. So for native packages, and two different models for non-native packages. Native is easy. You are the upstream. You only have the packaging or master branch. You can make everything there, release whenever you want, and no need for separate upstream or upstream branch or any separate patches or anything. Nice and easy. Then for non-native packages, this is the option I demoed here and had in the earlier pictures. You have basically two branches, or possibly pristintar as well. Separate branch for upstream sources, and then packaging branch, which is based on the upstream branch. The bad thing in this model is that when you do rebases, you lose Git history of the packaging data. And well, but it's easy to use and understand, easy to maintain. Then there's second option, which I shortly described with this one tool. There's totally separate packaging branch, and then upstream, and a separate development branch in which the source code development is done. So in this model, you have to use the separate tools for exporting the patches into the packaging branch and commit them there. Bit more complicated probably, but then with this you always have a linear history in the packaging branch and can easily see what has happened there. Okay, future development. Skip the demo. changelog generation is still missing. I hope to get it here, but didn't quite make it. Better support for bare repositories in order to more easily use the tool in the backend services, for example, remote builders. Then cross-distro support so that you could easily use the Git build package toolset to maintain packages for Debian and RPM simultaneously, or release easily for Debian and RPM. And then also some ideas of submodules to be able to create more than one tarball, source tarball caching. Then I had also in works an OBS source service plugin that the OBS server could use Git build package to easily fetch the right version of a package and build it. And then the name of the commands are not that nice, so I'd like to have like a nice subcommand interface, so GBP build and then give and GBP import. And then the usual. I'm not that fond of all or that proud of the code quality in all of the areas. So code cleanup, of course, then upstream all of the patches, and full unit tests are also missing. Some of them are already there, but not all. I'll skip this. Well, if you're interested, you can find me on IRC. Sources are in GitHub and documentation as well. And Debian Git build package easy to find as well. Thank you for your attention. Any questions?
Use the microphone.
Oh.
Thank you very much. I think you went a little bit quickly as regards the OBS business, but this is really interesting because that could be the interesting way to support at the same time multiple Linux distributions. So can you elaborate a little bit more on what's happening in that direction?
So as I said, I have a preliminary like OBS source server plugin for using Git build package. So the idea would be, in the OBS side, idea would be to use this. I don't know if you're familiar with this OBS source services. I guess you are. So to just have this one service file on the OBS side and run the service, and then the OBS server would use Git build package to fetch the correct or update the Git or clone the Git or fetch it. Use Git build package to export the packaging files and source files into the OBS server and then build it from there. So if you want to build certain version of the package, just click and then OBS service plugin would handle everything automatically. So I'm hoping to have this soon.
You said you did not want to reinvent the wheel.
Yeah.
I noticed that Fedora has been building packages from Git repositories. Can you elaborate on why you do not use their existing system?
I'm not actually that familiar with the Fedora style of maintaining packages in Git. So probably, well, at least at that time, I didn't like find anything that useful in that direction. Probably I just missed then something.
On your roadmap, do you plan to merge upstream, or upstream isn't interested into RPM support?
Yeah, the plan is to.
Okay.
Long-term plan is to get everything upstream.
And At the term, it is possible to build RPM packages on Debian system using this tool?
Yes, it is if you have all the RPM build and everything that
Sure.
is required. But otherwise, yeah, yes. Basically, if you have
And
the build
manage
tool.
both on the same with the same tools.
Yeah,
Okay.
yeah. That's the idea.
So this seems to work quite great if you have a source RPM to start with.
Yep.
Can you start completely native, just an upstream tarball?
Yeah, sure. Yeah,
so-
but then
so-
you just have to write the spec file yourself. But yeah, sure.
Sure, but
So-
all the examples are always about importing an existing source RPM. So if you're starting to build a new package, it's hard to get started, right?
Well, then you have to write the packaging from scratch. So import
Yeah, of course.
sources or just clone the upstream and
Yeah, of
Yeah.
course, of course.
yeah. Yeah, time's out. Thank you guys and ladies.